Let's discuss JVP today. So, JVP is jugular venous pulse. This topic, particularly, I felt it's tough to understand, but after understanding this topic, it was not that much tough how much we make it. So, let's discuss. First, internal jugular vein is open into superior vena cava. This is my internal jugular vein, which opens into superior vena cava, which further opens into right atrium. Okay, so the right atrium pressure is transmitted to jugular vein as there is no valve present. So as there is no valve between the internal jugular vein and right atrium, when right atrium pressure changes, it will reflect in the jugular vein. So let's see first, from the center of the right atrium to the upper blood level of jugular vein is 8 cm of water, the pressure. And this is our sternal angle. So from this to right atrium it is 5 cm of H2O. So obviously if we will check from sternal angle to the upper limit of venous pulsation, we will get 3 cm of water. So if we'll tell definition of JVP, it should be the vertical height of venous pulsation upper limit from the sternal angle. So from the sternal angle to the venous pulsation upper limit, this much height is called as JVP. Now let us discuss about different waveforms. This is the waveform of JVP, which has positive wave A, C, V. A, this is positive, C is positive and V is positive, whereas negative wave are X and Y. This is X and this is Y. Understand this waveform with the help of this diagram. So the first wave A. We'll discuss about wave A. In the first, the right atrium will contract. It will contract, due to which pressure will increase, and this pressure will give rise to this blood level. Okay, so blood flow will be in the upward direction. Therefore, it will go like this, okay, in the upward direction. So this is the A wave. Okay, as atrium is contracting, the blood level in jugular vein will increase and hence it will go in a positive direction. We can say that A waveform is due to atrial contraction. Okay, now let us discuss about wave C. So after the right atrium is contracted, blood will go to right ventricle. Okay, so blood will go through right ventricle. This is the tricuspid valve. So blood will go to right ventricle. Blood goes into right ventricle will contract, due to which blood level will move downward. As the blood flow is like this blood will come down and hence this level will decrease. Okay, so therefore after A wave there is decrease. Wait, but what, this C is again upward. Let's discuss this also. Okay, so as blood is flowing in right ventricle, there will be rise in intraventricular pressure. Therefore, there will be closure of tricuspid valve as the right ventricle will contract, and therefore there will be increase in pressure in right atrium due to closure of tricuspid valve. and therefore due to increase in pressure of right atrium, this blood flow will go up. Blood level will go up, due to which there is a small up, as we can see in C waveform, this portion. Now further, as this ventricle is contracting, the atrium will go into relaxation and the pressure will fall. Due to this pressure fall, the blood level in jugular vein will come below. As we can see in the waveform, it is coming below. Okay, this one. After the atrium is relaxing, blood level will decrease, and therefore from the body will be here somewhere, and from that tissue deoxygenated blood will come again to replenish this volume of jugular vein, and therefore due to more blood addition, the blood level is again increased, and therefore there is a formation of wave V. This one is the wave V, as I have shown here. This one is the wave V. Now after here the blood level is increased, we can see there is again decrease. But why? Just because again after right ventricle will relax, this right atrium, the blood from right atrium will flow into right ventricle, due to which this blood level will come down, as we can see in this graph. So this is the waveform ACXVY.